as its value. Are we doing okay so far with this? No? Okay. Maybe if we use GDB and the sample program, it will be helpful. Okay, so let's go ahead and do that. This is also, one way to kind of approach this class is not to just read the notes, or watch the video again, but to, write very simple programs to help you understand the concept. Okay, so we'll go ahead and make a new folder for today. And we'll go ahead and write, this is direct operand, so we'll just say direct.s. Dot data. In this case, I'm going to start with a particular value. So I'm going to use L1 here, and we'll say dot end. Give it a specific bit pattern here. So we'll just pick something that is unique. 0, 1, 2, 3, 4, 5, 6, 7. Okay. And then we'll switch back to dot text to write our instruction. We have to remember to export the label _start. And then we can start the entire program _start. If I want to debug from the very beginning, I have to put no op here because I cannot put a breakpoint on the very first instruction at _start. So now we can go ahead and try something here. In fact, what we'll do is we're copying the 4 bytes starting at label L1 to a particular register. Let's say EAX here. Okay. So this time I am using L1, which is a memory operand, as the first operand, which means it is now acting as the source. Okay? And just to contrast this with immediate, I'm going to do the same thing in the next instruction. I'll put it into EBX. So this way it's easy for me to show what is in EAX and what is in EBX. And let's just say that that's the end of the entire program. Just as good habits, I'm going to finish this program with the proper exit code, even though I will probably just skip that part and get out of the debugger because there's no need to track this program all the way to the end. This is my little sample program to help me understand, okay, what is the difference between L1 and $L1? So this is what I'm talking about when I said in this class, it is helpful to write simple little programs to help you understand the effect of instructions, operands, and stuff like that. Reading the note is good, okay? You should read it before the class so that by the time I'm talking about it, you have some idea of what I'm talking about. Paying attention in class is definitely helpful because you can actually see what I'm doing on the screen and my explanation of the concept. But after the class, it is always helpful to write tiny little programs, like something like that, to confirm your understanding of the material. Okay. All right. So let's go ahead and assemble, link, and go into the debugger to find out exactly what this program is going to do. I'll put a breakpoint on line 9, which is the first instruction. Run the program at full speed. This is right before I get to the first instruction, before it executes the first instruction. I would go and try to figure out what should be in EAX before I trace the program. Because if my prediction is wrong, that means my understanding of the concept may be incorrect, and then I will have to try to understand the concept properly. So that's what I would do. Now, according to the description that we talked about a little bit earlier, L1 without a $sign is a direct memory operand. In other words, L1 as an expression is not the bit pattern that we are copying. It is the location of the bit pattern that we are copying. So now the question is, what is at the location starting at L1? It's 0, 1, 2, 3, 4, 5, 6, 7 as a hexadecimal number. Okay? So that means if I single step this instruction, now EAX should have that particular bit pattern, IR EAX, and it does have 1, 2, 3, 4, 5, 6, 7. Remember, the 0 is a leading 0. It is not printed. Are we doing okay so far? Yes? Okay. You can also see that it can also be displayed as a decimal number, but in this case, it really is not important. Now we are trying to deal with the second instruction. This is our second instruction. This time we have a $ symbol in front of it. So the question is, what is that going to do? Well, what that is really saying is we don't care about what is at location L1. We are copying the value of L1 itself to EBX. So let me say that again. The first instruction is copying whatever is at location L1 to the destination operand, which is EAX. The second instruction, the one that is highlighted at this point, is copying the expression L1. Whatever the expression L1 is, okay, it's copying that bit pattern to EBX. Okay? What is L1? Not what is at L1, but what is L1? We normally don't care because we don't have to deal with that. You can actually say print L1, and it will give you what is at that location. So if you really want to find out the label L1 itself, you will have to do something that looks like this. Okay, the address of. Now this is an artifact, because the debugger is leaning on interpreting things in a high-level language way. So it is naturally interpreting L1 as the address of an integer. So you have to put an ampersand in front of it to get to the actual definition of the label L1 itself. Okay. So I would say that after the second instruction, EBX will have this particular value. Single step, look at EBX, and sure enough, it has that particular bit pattern. Are there any questions about what the $ means or their lack of? With the $, whatever the expression is the value of the operand itself. It can only be the source operand because it's an immediate operand. Without the $, the expression specifies the location where you will grab 1, 2, or 4 bytes to be the actual bit pattern to be copied. Is that okay? The difference is subtle, but it is very important. Yep.
So if you kind of like pointers in C, would it be the asterisk L is kind of like dereferencing the pointer? In this case, you're using a $sign.
Okay. In this class, in this particular session, I can kind of use a C notation to kind of help people understand approximately what it is. Okay, but it's not exactly that. Okay, you can look at the $ symbol as the ampersand symbol, roughly, approximately, kind of. Okay, I have to really emphasize a lot of stuff because it's not exactly that. Okay, so the $ symbol is kind of like ampersand, which is the address of operator in C and C++. Okay, so without you're actually accessing the quote-unquote variable itself. With it, you're trying to specify the address of the variable. Now, I have to really emphasize, it's kind of like that because, let's go back to our example here. Because using that particular example, this makes no sense, right? What is the address of 0? No, the address of 0 is undefined because 0 is a constant, it has no address. So that interpretation or the parallel between the address of operator and the $ symbol, which means the immediate operand, is really a way to help you bridge from what you understand in C to constructs in assembly language programming. But it is very misleading. Okay, it is extremely misleading. Is that okay? Okay. Yep.
So what's the purpose?
The purpose of
the immediate operand.
The purpose of the immediate operand is whatever is next to the immediate operand, in this case, 0, is the source operand.
But, I mean, where would you use it, is what I mean?
It can be used as a constant. So if you want to initialize a register to a constant like 0 or 1, then you should use the $ symbol. So you say $1 or $0 to specify the actual value of 0, the actual value of 1. Now without the $ symbol, you're now specifying the content at the address 0. Okay, yep.
So that does not apply, for instance, on the line that's labeled label 1:, dot int and then 0x5, because 0x5 is being interpreted as a value, not as an address.
Because that is the content, that's the bit pattern of the 4 bytes that you are allocating. Am I explaining that right or not?
As long as I keep in mind that it's not, it's the difference between a declaration and an expression.
Okay, let me go back to this, the source code of this program, and we'll take a second look at this, and then I'll explain, each line again. And if you have any questions, this would be a good time to ask. L1 colon. Okay, L1 colon means I'm trying to define a label called L1 to be the current address in the dot data section. Okay, remember the dot data section is used to store things that can change over time. We're doing okay so far. Okay. So L1, you can interpret L1 as a label to be defined as an address at this point. But an address is nothing more than a 32-bit bit pattern. You can see it as an address. You can also see it as a signed integer. You can also see it as an unsigned integer. You can also see it as 4 bytes, 4 individual bytes. Okay? And that's the whole point of assembly language programming is there is no such thing as, oh, these 4 bytes is a 32-bit integer. No, those 4 bytes is nothing more than 4 memory locations. Each memory location has 8 bits. That's all. What is actually assigning quote-unquote meaning to those locations are the instructions. Okay? So the instructions dictate how you interpret something. It is not the definition, it's not the dot int, the dot byte, the dot fill. It is the instructions themselves. So in this case, L1 is being defined as a label. It is the address of the first byte of whatever is following. If you have a dot byte following it, it'll be the address of the dot byte. If you have dot ASCII following it, it'll be the first byte of the dot ASCII. In this case, we have dot int. When the assembler sees dot int, it will understand that we are trying to allocate initialized bytes, following the dot int. Okay, and those 4 byte things are separated by commas. We don't have multiple things here. We have one single thing. So what the assembler is going to do now is to look at this particular hexadecimal number and say, okay, we have to allocate 4 bytes, and those 4 bytes together will represent this particular value, which is represented as a hexadecimal number. And it will make sure that these 4 bytes will be initialized with that particular bit pattern. Are we doing okay so far? I'm basically dissecting each line the way the assembler is going to see it. Is that okay? Yep.
Is dot int a directive?
Dot int is a directive.
So is it basically the same thing as dot data and dot text? I mean, is it the same?
It's in the same general category. It is instructions for the assembler itself. But in this case, it does use a byte because it is telling the assembler allocate 4 bytes, and those 4 bytes will represent this particular value.
Compared to C, would it be kind of like you're comparing L1 to the int and 4 bytes?
For only this class session, yes. Okay, for only this particular class session, this is almost saying static int L1 equals 0x